All right, so this second half of 7.5 is going to focus on the kite. So we have two theorems regarding the kite. So we have the kite diagonals theorem, and then we have the kite opposite angles theorem. So the kite diagonals theorem tells us if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so remember what perpendicular means. Perpendicular means it crosses at a right angle. So each of these are right angles. Okay, the kite opposite angles theorem tells us that if a quadrilateral is a kite, exactly one pair of opposite angles are congruent. Now the way I like to teach this is so if I have a kite, and I'm just going to draw one of the diagonals, okay? So we know that this side and this side are congruent. We know this side and this side are congruent. And then this side here is reflexive. So I like to think of kites as like two congruent triangles, okay? So if you think of these as two congruent triangles, of course, this angle and this angle would be congruent. But also, like this angle that's split and this angle that's split would be congruent, and this angle would also be congruent. All right, so let's look at example 6. Okay, it says find angle D. So I'm going to think of this as two congruent triangles. Okay, so if these are congruent, then that means angle D and angle F have to be congruent as well. Well, I know in all quadrilaterals, all interior angles add to 360. So I can say 115 plus G plus, I don't know, we can call it X and X. X plus X equals 360. Sorry, angle G is 73 degrees. So if I clean this up a little bit, I get 188 plus 2x equals 360. If I subtract 188 from both sides, I get 172. And then divide by 2. I get x equals 86. So this would be 86 degrees, and this would also be 86 degrees. All right, go ahead and try to do example 7 on your own, and then we'll go over it. All right, so example 7 says, in a kite, the measures of the angles are 3x, 75, 90, and 120. Find the value of x, and then what are the measures of the angles that are congruent. All right, so to find the value of x, once again, it's a quadrilateral, so it all has to add to 360. So I can say 3x plus 75 plus 90 plus 120 equals 360. If I clean this up, I get 3x plus 285 equals 360. Subtract 285 from both sides. That gives me 75. So 3x equals 75. Divide both sides by 3. I get x equals 25. So that's my value of x. So if x equals 25, if I plug it in here, I know this is 75 degrees. So the two angles that are congruent would be these two 75-degrees. All right, so example 8 says, what is the most specific name for quadrilateral ABCD? So I want you to look at this, come up with the most specific name, and then we'll go over it. Look to see what is given. What can you conclude about this diagram? So the only thing you could really conclude about this diagram is that the diagonals bisect each other. Okay, we know nothing other than the diagonals bisect each other. Okay, so the only thing we could really call this other than a quadrilateral is a parallelogram. All right, so example 9 tells us that quadrilateral DEFG has at least one pair of opposite sides that are congruent. What type of quadrilaterals meet this condition? Okay, well, we know that all parallelograms do, because both pairs of their opposite sides are congruent. So on a parallelogram, that is a rhombus, that is a rectangle, and it is a square. So all of these. Now a kite has adjacent sides congruent, but opposite sides are not congruent, so not a kite. And then not a trapezoid, but an isosceles trapezoid matches this as well. I think that might be an E. All right, so last example, I want you guys to go through, do ABC on your own, and then we'll talk about them. Make sure you only look at exactly what is given. You can't assume something if it's not given to you. All right, so here we know these two are congruent, and then we know these two are congruent, but notice that the opposite sides are not congruent. Okay, so all we know this is a kite. That's the definition of a kite. Both pairs of adjacent sides are congruent, but opposite sides are not congruent. So A is a kite. All right, B, we know that this side and this side are parallel, which gives me a trapezoid. And notice that this plus this is not equal to this plus this. So the diagonals are not congruent, so it can't be an isosceles trapezoid. So trapezoid is just the most specific name we can give. All right, let's look at C now. We know that this side and this side are congruent. And then we know this piece and this piece are congruent. But we don't know that this piece here and this piece here are congruent. Okay, so really there's nothing other than a quadrilateral that we can say is true about C. We just don't have enough information to say any other thing.